In this video, we are going to be doing two examples of solving for x when we are dealing with inequalities. So in this case, our answer isn't going to be one or two values for x. Our x is going to be a whole range of values. Like, for example, x is going to be bigger than 1. Then it can be any single value that is bigger than 1. Let's read the question. Solve for x in this inequality and illustrate your answer on a number line. Okay, so we need to make sure that we remember to do that. And give your solution in interval notation. Okay, so they're also very specific in which format or which notation they want the answer. Let's get going. So since this is our inequality, we are just going to, for a brief moment, just make this equal to 0 so that we can go find our critical values. So let's go factorize this. Got x and x. Let's think about those factors and what they can be. Obviously, I know that many of you use your calculators, and if not, this is a pretty standard trinomial where we just have a coefficient of 1 there. So it must be plus 3 and take away 2. That should work. Yes. Okay, so therefore we have our critical values. Our critical values would be -3 and 2. So now what I see a lot of students do is they just say, okay, x must be smaller than 3. They just kind of guess where the x values will kind of fall, if I can put it like that. But what do we need to remember? I know there's some of you that uses a number line to find your answers over here, but I just use, if you use that, make sure that you just get to the same answer as we do. I'm just going to go draw a parabola. So let's look at our given inequality over there. It's in its standard form, so that's why I'm going to look at that one over there. That would be a happy face parabola, right? Why do I know that? Because my coefficient of positive 1 there. So it will be a happy face parabola, and my critical values will be by -3, we just found them, and then by 2. So it doesn't have to be this perfect, did I say parallelogram? Parabola. There it is, so it looks more or less something like that. Then, in that highlighted green standard form parabola over there, we look, it says over there that it is where our parabola is bigger than 0 because of our sign. Hey, I feel like that's messy. So it says where our parabola is bigger than 0. Well, our parabola is bigger than 0 there. Okay, perfect. And there we have our answer. So it will be all the x values that is smaller than -3 because that will be included in the solution. And all of these x values will be included in the solution. So I'm first going to write it in just as an inequality. So x will be smaller than -3. I'm not including -3 because it wasn't included in the question like that, remember? And then, or x will be bigger than 2. Now let's go put that as interval notation. So for interval notation, it would be that x is an element of from -infinity, that is never included, right, to -3, and the 3 is also not included, so a round bracket, not a square bracket. And then x is an element of 2. 2 is not included, therefore we have the round bracket, and going up to infinity. There is our interval notation. They also want us to go illustrate this on a number line. So if there is our number line, 0 is somewhere there, 2, 3, 4, 1, 2, 3, 4, and then -1, -2, -3. So if we illustrate it on there, 2 is over there, x will be bigger than 2, so it would look something like that. Remember, it's a hollow dot because 2 is not included, but any value bigger than 2 will be included. And then hollow dot because -3 is not included, but then any value that is smaller than that will be included. And there is your solution. Let's just quickly recap. So we had our inequality given there in its standard form. X squared plus x minus 6 is bigger than 0. Just for a moment, we made it equal to 0 so that we can go calculate our critical value. So we just factorized to get our critical value. We knew that it was a happy face parabola. So we just plotted our critical values and drew a rough parabola. And then the important part that I find students forget is, do we highlight the top part of the parabola or do we highlight the bottom part of the parabola? And how do we know? Well, you look at your given inequality in its standard form and we see, okay, wait a minute, it is where the parabola will be bigger than 0. And then we know which part of the parabola to highlight and where the solutions will be. Let's look at a second example. Notice with this one that it is already in factored form. What I find that a lot of students do is they go start multiplying it out using FOIL, and then they just factor it again. So you basically just going backwards. Anyway, if you do that, that's fine. You just wait a little bit of time, but so watch out when it is already in factored form. So from there, we can already go find our critical value. So just for a moment, I'm just going to go make that equal to 0 just so that I can calculate my critical values. So my one critical value is 1 and my other critical value is -4. Okay, so we're going to use those critical values to draw a rough sketch of a parabola. Is it a happy face parabola? Well, we know if we're going to start multiplying this out that it is going to give us a happy face parabola. And then we need to go plot our critical values. So we've got, we've got -4 somewhere over there. And then we've got 1. And there is our parabola. Okay, so far so good. Now, which part of the parabola are we going to highlight to get our solutions? Let's go back to our inequality there. It is where this parabola, because obviously if we multiply it out and it gives us that quadratic, it is just a parabola if we were to sketch that. It is where the parabola is smaller than 0. So where is the parabola smaller than 0? The y values of the parabola is smaller than 0 there. So that means that the solutions for my x values will be in between those two values. So let's go write that down. I'm just going to write it as inequalities first. When it is between two values like this, it means we're going to have one inequality. So x will be smaller than 1, but x will be bigger than -4. If we highlight the arms, these ones, like that, and they go their separate ways, that is when we have two separate inequalities, like we had with the first example, right? Okay, so now let's go write it in interval notation like they wanted us to. So x is an element of, starting at -4, it's a round bracket because the -4 is not included. Why not? Because it wasn't included in the question. If it was, then it would have been a square bracket. And then it goes up all the way to 1, which is also not included. And there is our answer in interval notation. Let's go draw this on a number line quickly. I'm going to just plot those critical values. -4 and 1 will be somewhere there. And then my -4 is not included. That's why it's a hollow dot. My 1 is not included. That's why it's a hollow dot. If the 1 was included and the 4 was included, I would have just colored it in like that, showing that they are included as part of the solution, meaning that x can be -4. But if -4 is not included, then it means x cannot be -4, but x can be anything that is to this side of -4, which will be literally all those values. Every single value that makes up that line will be included in this solution. And that's it. Find these questions on the worksheet that is attached. I'll put another link in the description to this. And make sure that you also try some of these on your own.